All right, Internet, welcome back. So we are doing part dos of Natas, Satan's fallen friend, or rap group in Detroit. So today we're going to run through level 7 through 10. I decided not to include 11 because it was getting very difficult. I found out the answer, but I will tell you the truth, I cheated through about half of these levels. And as these levels become more complex, I'm going to start including less of them in each video because I need more time to both understand it myself and also to be able to kind of regurgitate what I've learned to you for these videos. So with that being said, let's get on to level 7. So on level 7, we're going to do as we always have done, which is basically to check the inspect page. And if I look into the inspect page, we'll go to elements and we will recursively expand all of these elements once again to see what's inside of the body. As you can see within here, we have a hidden comment, and in the hidden comment, it states that the password for web user Natas8 is inside of this location and this certain file path. So first things first, I think to myself, okay, well, they're saying a file path. Is this just as easy as I think it would be, where I would just basically copy and paste this at the end of the URL and it would take me to the Holy Grail? And I did that, so I put it in here and press enter, and it says, no, you are wrong. That is not the right location. So after doing that and getting frustrated and doing it probably 3 more times, getting frustrated 3 more times, I started playing around with the web browser itself. So if you select home, you can see that this has changed. So this portion up here has changed. And what it's included is pretty important to point out. So up here, you can see that what it's included is a PHP index file. So basically, this piece here includes a certain path to this file, which is a PHP file, right? But the next piece includes a question mark. And you can see that here, if my little menu gets out of the way, there's a question mark here, and then there's a page equals home. So the next thing I thought to myself, I was like, okay, what does all this mean? So I actually started researching specific parts of a URL and what does a URL encompass? What is inside of it? And luckily, the Mozilla team, as usual, has created a beautiful summary, a blog, a guide, and all that stuff. So if you come down here, and I was reading through the anatomy of a URL, you can see that there's a pretty little image here. And in this image, it states a few things. And the thing that's most important to us is that when we originally put in the path that we assumed was the correct location, we thought we were going to this path based off of the path to the file. But remember, as I said earlier, the file that we're seeing currently is a PHP file. And inside of that PHP file, there's additional parameters that actually can trigger for the specific code that's sitting inside of this file. And one of those parameters that we've seen in the other location, in the other URL, if I jump back here, is going to be the home piece, right? So we have page equals home. So home is a specific location. Page is a specific parameter that we can call on, or a key. So you can see these are key value pairs. So if these are key value pairs and one of our keys is a path, then the next guess or assumption would be that if we paste in the path that's been provided to us in the inspect page, then we should hopefully be able to make it to where we want to make it. So if I expand this, let's get back to where we were, is this one here. And I can't really copy it from there, I'm sure you can, but it doesn't seem very easy to me. So if you actually copy and paste this piece here, and you place it into that value piece for that key. So instead of going home, we're actually going to go to the Etsy folder, the etc folder. We're going to go to Natas web pass, and then we're going to go to Natas 8. And if you go there, it's going to drop you a password, and it's going to give you the key that you need. Now, when I did that originally, I wanted to see where else I could go. So I started playing around with this and trying to see if there was any other locations I could go to just out of interest. And you can see that every single time you do that, it just kind of errors out. So now that we have our password, congratulations, you are officially a 7-level ninja at Natas. And I promise you, as usual, that seemed easy. It seemed obvious, but it was not. It was by very little means it was obvious to me. It took me, I'd say, roughly an embarrassing like an hour to figure that out, because I had to basically, go through here, figure out what the URL path was. And actually, let me explain what happened there. I forgot to actually mention that. So if we bounce back, let me bounce back here. What we included here and what happened here is we actually included a file path here, and that file path was it's considered a specific type of attack. So let me go out of here, and then here's a few other tabs that I've actually read through for that hour. The first part I'll talk to you about is a file inclusion vulnerability. And the file inclusion vulnerability that we were specifically looking at is called a local file inclusion. And the reason it's a local file inclusion is due to the fact that what we were looking at was a local file. And it was a local file sitting on a server somewhere. So basically we have, our computer, and we have a server here, we'll call that an S and a C. And then we have, a whole bunch of other servers here all throughout the internet, right? And there's a server that's sitting close to us, aka local. That's why they call it local. And what we did is we actually pinged out to that server, and we adjusted the path. And when we adjusted that path, that server took us to a certain location that we shouldn't have had access to. And when it sent us to that location, it actually spat back that code that we needed. And that was our key that got us to the next level. And this is something that I had to kind of read through and understand. And after kind of perusing this article and reading through the different types of ways that people actually exploit this vulnerability, I realized that there was a specific way of actually adjusting the path variable. There's obviously some information here where you can not just go to a specific path, but you can actually go up a tree. And that's something we'll get into in the next one because hint, hint, that's in there. But that's something I wanted to point out there is that I did a lot of reading into file inclusion vulnerability, what it was. I also went to the OWASP website, which was useful as well. Another thing I wanted to point out here is directory traversal. And we can, actually I'll explain this in the future one, but what we did there was a type of path traversal or directory traversal, which was basically going from, one location, which is a / this location, and then we changed the path and we went to a different / location, right? Alrighty. So on to the next one, Natas 8. And so Natas 8 is, slightly different. We have a few different things here that we don't necessarily even have to inspect the page. We can kind of just play it around and see what's here, and you can see a lot of the random stuff I was putting in here. A few of the things that are auto-completing here is I wanted to see if there was any way to include brackets to do some sort of kind of XSS attack where it actually, and takes that specific symbol in, and it's not doing any sort of sanitization on this side. And sanitization is basically when you send off something through an input, the coder that had built the application is basically ensuring that certain characters are inside of there to prevent themselves from getting some sort of injection attack, or at least bucketing those symbols into something that protects them. And I'm sure I'll have a better explanation of that in the future once I've run through this kind of thing many, many times. Anyways, so if you can see once you put something in here, you can see that it automatically poops back wrong secret. And the secret is unknown to us, and there's a view source code here, which is nice. This is not something that I'm sure you would run into in the wild, but it's nice that they provided to you so you can learn. And as usual, we don't necessarily have to look at any of the header. Remember, in the previous sessions that we've had, is basically this entire section is useless. Not useless, but in this challenge, we don't really care about it. We want to focus on the things that matter. And if you come down to here, you can see that we have a block of PHP code. And you know that it's PHP code based off of these brackets and these question marks, which kind of signifies where the PHP code sits within inside of an HTML page. And here, as usual, I would jump right down to here and skip the thing that actually matters. But luckily, I didn't skip it too quickly this time. I actually read the entire time, learning from my previous experience. And in here, you can see that we have a specific variable called encoded secret that has a secret here. And right below that, you can see that there's some magic happening here for that encoded secret. So we have a function here, right? And this function is taking a secret, and that secret is going to be in our encoded secret, right? And when we include that, and the reason I know that, let me take a step back. The reason I know that's what we're putting in there is because you can see that down here, we're basically checking our function against the encoded secret. So we want to make sure that this secret matches the encoded secret that we have here. And what's happening here is that we're basically encapsulating a few things. So we have this function here, which isn't really necessarily a function. It's a series of functions that are occurring simultaneously. First, we have a base 24 encoding. So this first one here is a base, not 24, 64. 42 is the only thing that matters anyways, right? And then we have a string reverse function. So it's strrev, and that's a function. And then the last one is a bin to hex. And to be honest with you, with the internet, the only one I knew about was the third one. So the base 64 encoding, this one. The rest I had to Google. And when Googling those, I had to figure out each one of those. And I first started out actually with the bin to hex. So first I wanted to say, okay, what in the heck is this? Like, I have a general idea that this is probably reversing a string. I know what base 64 is and how that encodes. I know what hexadecimal is, and bin binary, I'm assuming, is what that is. But what does this function do? How does it work? And when looking in here, you can actually see that it's not necessarily always binary to hex, but here you can see that what it does is it returns an ASCII string that is a representation of hexadecimal. So once I seeing this, I knew that basically what I needed to do is I needed to reverse this encapsulation to get the secret that mattered to me. So I need to basically run this backwards through this series of functions here to get the answer. And coming in here, you can see that, okay, so if it converts ASCII containing hexadecimal representation, I'm going to do that backwards. So what I'm going to do is I'm basically going to convert hex to ASCII. So if I take this secret here, oops, if I take this secret here, and I put it into this online converter from hex to ASCII, it's going to give me back some gobbledygook that looks like big 64 reversed. So instead of typing that backwards and reversing it, I just found a reverser online, and you can easily just paste it in there. It reverses for you, and then you got your base 64 encoding. And the reason I know it's base 64 is not because I'm a genius or anything. It's because obviously you know I'm not after following along here. And the reason I know that is because here we have a equals at the end. That's not always the case, but it's most likely the case often. And I think it might actually always be the case. I'm not really sure. But that's something we can Google. And here, if there's an equals at the end, my immediate assumption is that, okay, this is base 64. So the very next step is to basically decode this based off of the previous series of functions. So we're going to take this, we're going to put it in there, we're going to decode it, and then out pops a series of letters that looks like a potential secret. So I said, okay, well, if that's the case, let's pop it in here and see what happens. And then bada bing, bada boom, we have our answer. So that was that episode and the Natas 8. So now let's go to Natas 9. It's only going to get more difficult from here, I promise. It never gets easier, sadly. So, or not sadly. Anywho, so here we have another situation where we have an input and we have some sort of output. So we're going to come in here and I'm going to put in some stuff and see, what pops out. So if I put an S, then I get a whole bunch of crap here. And it looks like what's happening is anytime I put an S, S is inside of a word, obviously. So if I do, say, apple, or if I can spell apple right, put an apple, it's going to give me a whole bunch of stuff that includes apple inside of the word. So pineapples and grapples. It's like grappling. Anyways, so you can see that's the case. And if I back that up, we're back to the place where we were. One important thing I'll point out here is when I do this, you can see that there's additional keys. Remember how we had key value pairs? We have a key of needle and a value of apple, and we have a key of submit and a value of search. So those are something we should kind of consider. The next is we're obviously going to go to the source code and see what's behind this, this hidden little gem here. And this one took me a long time, internet. This one took me a while to figure out. And the reason being is that I had to really learn a lot from scratch. And the thing about learning from scratch is I tried to do everything I could not to cheat, because it's really easy to cheat on these CTFs, especially ones that have been around for a long time like this. And you can easily just look up Natas 9 on Google and it'll give you the answer. I did actually look up the answer, but I didn't cheat all the way. I cheated halfway. And luckily, some kind souls like Nopi write these tutorials where they don't necessarily automatically give you the answer, but they kind of give you hints along the way. So you have a few hints here where they talk about a few items, and they're actually kind of breaking down the challenge, similar to what I'm doing for you on this video. And when they're walking you through this, they're giving some hints. And the initial thing I actually did, which was useful and helped a lot, was actually looking up the pass-through function. So I basically Googled this pass-through function and saying, okay, what is this? And let me actually go back to the code and kind of walk you through some important pieces here. So we have, at first, we have a key, right? So we have a key variable here that takes an empty string. And then below that, we have array key of exits, and that's going to take the request, and it's going to take in the needle piece. And then we're going to do some stuff with that request. We're going to put it into another variable, and then that's going to kind of feed us back something else. But the important piece here I want to basically show you is that if the key is not blank, then pass through this information. Now this pass-through function, I didn't know what it meant, so I wanted to Google it and figure out what that meant and what it was. And as I was actually Googling this function, I learned that this function specifically, let's jump into the manual for PHP, which is what I went to initially. If you scroll down past the description, quickly what it does is it's a command that will be executed Basically, you pass in something and then it pops something out. That's really the purpose of this function. Let's see specifically what it states. All right, so what it really does is, if you look at this first statement here on this sentence, it kind of gives you an idea. Is what this does is it takes a command, whatever command is passed into this location, right? And then it executes that. And they state that it's very similar to the exec function, which is the execute function. And what we're doing here is, in the code, you can see that we're passing in a specific command, and that command is going to be a grep-i, which is basically case insensitive, the thing that we've put in there. And then what we're going to do is we're going to grep for that thing inside of this location of dictionary. So let me kind of try to explain that with a pencil, because that's why we have it, right? So in here, what we're doing is we're going to grep, right? So we're going to grep is basically search for a case insensitive term. And this term we're searching for is going to be inside of this dictionary. So once we've found this term in this dictionary, then it's going to spit out everything else. And that's similar to what we did. So last time we put an apple. So this would be the apple piece here, right? A. And then out pops, grapple, apple, all that stuff. And once learning that, figuring out what this was, if you actually scroll down a bit further on the page, there's a massive warning sign here. And this warning sign basically states that this should never really contain user-supplied data. And you can see that right here as allowing user-supplied data passed to this function. And then it basically states that you should use these alternative functions to actually encapsulate that function. So you're escaping any arguments that could be put inside of a command or a shell. And you can see the escape piece here. And what that would look like is, let's see if they included it here. What we could do is we could actually just control find. Let's do a control find, escape. It doesn't look like they've included it, but it would basically encapsulate inside of this. We'd have the pass through. So once I realized that this was an issue, and if you pass an arbitrary command into pass through, it's going to execute it no matter what. There's going to be no sanitization or anything. That was kind of a good insight. And then I started, cheating a little bit more and trying to figure out what else they said without trying to cheat too much. And they started talking about command injection, specifically shell injection. And here you can see there's some mentions around shell injection on Wikipedia and code injection. I read through the article, read through the piece on Wikipedia, and understood that this is a common occurrence. And this common occurrence actually happens for many reasons, but usually the user input that has it occur has to have a series of symbols prior to the command you put in. So when I initially did this, I was like, okay, well, if commands are all I need to do, then if I just put in, ls, whatever, then it should give me back something. So if I do ls -al or la, it should give me back everything I need to see. But in reality, it's not doing that, because what the input is seeing is just ls. It's not seeing it as a command itself. So you can see basically ls included for all of these is what's returned, and that's not what I want. So then I struggled with that for a little bit, kept on putting in stuff into this input and getting failures and failures and failures. And then when going back to the Wikipedia article, I realized that there was a beautiful, table here that talked specifically about pass-through and how there was an issue with web servers and command injection for web servers and for pass-through. And you can see here there's a table of symbols stating what the user input is and then how people actually attack this. And the one thing that I really needed to know, and if I would have taken my time and probably read this thoroughly, I would have seen that the semicolon is needed so that the text after the semicolon is actually considered a command. And what that is it's basically within a terminal or in a command line, the symbol here, this semicolon, is basically stating it wants to have a sequential execution. So meaning if we jump back to the source code here, you can see that if we include the specific semicolon after this, then it's going to consider it a command instead of just text. Because right now we have grep-i, but if we had a semicolon after the -i and included ls, then what it's going to do is it's going to consider grep-i as one command, and then we're going to have a semicolon ls as the additional command, and that ls is going to basically ls this or whatever else we want it to do. So that's one thing that I struggled to realize, and then finally came to the realization that was the case. So for example, let me show you if I do ls here and then -al instead of what we did previously without the semicolon, it's actually giving us back what we expected if it was actually in a shell. And that's just one of many options here. You can see that they have the straight bar. You can do backdashes. You could do different types of $signs, etc. And these are all different forms of attack that include the symbol and then the command you want to do. Then I actually came to the OWASP section and read more about this and read more about command injection and things like that. And I wanted to figure out what specifically I needed to do to get back to where I needed to get. And I wasn't necessarily sure where I should go. So what I started doing was just going backwards up the tree. And that's the directory path reversal that I mentioned previously. So if I actually do some dots and dashes, what each of these are doing is it's basically taking me back the directory. And to show you that, kind of the dot and dash here, every time I do a dot dot dash, it's going to take me up the tree. So imagine you have a tree, right? So you have an item here, an item here, an item here, an item here. And we're actually, say we're here, right? This is where we're located. And we want to actually get to here. This is the goal. And inside of here is our secret. Say that's the case. So to get back every single level, we need to include a dot dot dash. A dot dot dash, dot dot dash, dot dot dash, etc. And that's going to take us up the tree, and that's going to get us to where we need to go. Here you can see I did, in the input, what I put in was an ls dot dot dash a few times, taking me up the tree, and then lsing out whatever was in that location to see what was in the list. And as you can see, the further I go up this tree, the further you can see I'm getting to a certain location. And I kept on doing this, honestly, until it stopped, right? So let me do this and add another one. And you can see now, as I put this in, we're not moving anywhere. It's just adding another dot dot dash to it, but not really taking us anywhere because we all have the same folders. And then the next thing I thought about was in the previous episode of this series of videos in Natas 8, it showed a specific folder was etc Natas web pass, and then the Natas location we wanted to go to. So my next assumption was, okay, well, if that's the case, then maybe we need to go to etc. So if I put in etc, it's going to take us to etc. And then I scrolled through here and said, okay, does it have the last previous item that we had? And you can see that it does here. So if that's the case, then I'm going to basically jump into that. So we'll do that, and then we'll jump down here and copy and paste because we're lazy and it's faster. I put that in, and then it's going to take me to this location. So it has all of our folders and everything that we need here. So now that we're in Natas 9, what we want to do is we want to cat out Natas 10. And cat is basically read out. So I want to read out the Natas 10, not 19, 10, and then I want to get rid of the ls that I put in there. Or no, it's fine. So if I do cat here, oh yeah, here's a good one for you, internet. I totally forgot about that. So if you have any type of antivirus on your machine, and I have Bitdefender, so basically what it did is it realized that when I put in this command, it was kicking back a specific key from the folder from a server, and it's sketchy to Bitdefender, and it should be to you as well. So what I had to do is basically open up Kali or whatever virtual machine you have. And in here you can see basically I was running through some commands here to see what specifically I could do, and you can see Natas 9. If I open this up, you'll see that basically it kicked back the key once I put in the code here, and it gave me my answer here. So that is how you go about doing it if you have a special antivirus on your computer. So we've gotten through Natas 9, and now we're going to go on to Natas 10, which is going to be the last one. A little bit longer video, but I promise they'll get shorter after this because we're not going to do so many challenges in a row. So Natas 10, next one. Now this is similar to the previous ones, so we're going to put in some text and we're going to see what comes back. And you can see specifically here that it says for security reasons, we now filter out certain characters. So this goes back to the sanitization piece. Because remember, as a developer, there's a lot that you have to do, and I feel like not many security folks give developers the credit, like the benefit of the doubt, because being a developer is really hard. Like building anything from scratch, or at least piecing together things to make them actually function at scale, is not an easy task. And thinking about security is just another burden on them. But with that being said, anytime you have input from a user like ourselves, and that input gets placed into some code, and if this code, and if this code doesn't have any sanitization inside of it, meaning if you inject some code and there's no processes behind the scenes to actually make sure that whatever is put in here is either encapsulated in something and interpreted as a string, or interpreted as something that's not malicious, then that's no bueno. So what we're going to do here is you can see that they're trying to sanitize some stuff. So we want to see what they're sanitizing, so we're going to go to the source code and we're going to see what specifically they're talking about. And if you look through here, there's a few things that really jumped out to me at first. So when looking through here, I actually jumped right down to the bottom, and I wanted to see what sanitization was happening, because you can see a lot of the code is similar to what we've seen in Natas 9. Really what's changed is, in the past we had the pass-through function, and now instead of having just the pass-through function, we actually have, in addition to that, we have a pre-reg preg match, which is regex, which is a convoluted alien language that very little people know about. And in this match, they're matching for a few specific items. So here you can see they're looking for brackets, they're looking for semicolon, straight bar, and etc. And if you think back to our Wikipedia page, which I'll pull up in a second, so here we are back on our Wikipedia page I was referring to. And on the Wikipedia page, remember that we had all these different symbols, right? All these different symbols that we could actually utilize to run a command within an input that's been provided to you and actually, execute something. And if you look back here, a lot of the symbols that we've relied on that have been useful, such as the backslash and the backticks and straight bars, etc., are all being sanitized. So basically it's stating that if any of these occur within the input, then I want you to output that this contains illegal characters. And to show you what that looks like, because remember how we did the semicolon ls? Well, that no longer is being accepted because they're actually sanitizing some of those characters within the source code. So the issue here is basically stating that we need to figure out a way to get in here without running what we've previously run and relying upon what we've understood from this table. Now, this took me a really long time as well, because I basically tried all these characters, and then I started trying a bunch of other random characters in here saying, okay, does this work? Does this work? Does this work? And it's a lot of just me banging my face against this input section and trying to hope to get something back, and it actually didn't work. So I had to cheat again, but a little bit again. So I didn't cheat the entire time. I didn't just get the answer. I slowly worked myself way through a certain tutorial, and I would kind of like peek at the next line and then peek at the next line. And then basically if anything jumped out on that line that I didn't understand, I'd Google it and research it and figure out, okay, if they know this, why do they know it and what does it mean? And specifically, one thing that jumped out to me in a previous tutorial I was reading through talked about grep and started talking about the utility of grep and what does it mean. And so what I did, the next step I basically took was jumping into grep itself here. So let me clear this out. Let's do a clear. And then what I did is I jumped in here and I wanted to say, okay, what does grep specifically mean? So if you type in the help for grep, or you can even just type in man grep, so it's going to give you the manual, or you can go to the help section. Either way, it doesn't really matter. If you go to the top here, you can see specifically at the top, it states that this prints lines that match patterns. The important piece here is patterns. So the next thing I'm going to show you is actually the grep for help instead of just the man page. So if I go into help and I scroll up to the top here, the thing that really jumped out to me when I was reading more about the function and the different types of, different parameters and stuff and switches that you could put inside of grep to have it act out a certain command, at the very top it states that patterns can contain multiple patterns separated by new lines. And another important thing is search for patterns in a file. And what jumped out to me is that it states patterns, right? It's not saying pattern or a file, but it's saying multiple patterns in each file. And what jumped out to me there is basically the fact that grep is not just looking for a single file, but it can look for multiple files. It can grep multiple files for certain locations, out certain items. And the important thing here is when looking at grep, you can see that it's taking in a key and it's looking at a dictionary. And if it's looking at multiple files, so if there are multiple patterns, plural, the S at the end of pattern, if it's looking at multiple files, that means that maybe what I can do is I can actually look at two files, one in one location and one in the other location. And what you can see, what we can do here is say this grep here, right? So if we're going to grep for this key, then this key should be not just a value, etc., but it should be a value and a location. So for instance, we could put in, A, and then we can put in our location. So if we want to do etc / whatever the web pass was, and then Natas, it's going to be 11. So if we did that, in addition to this, so the dictionary would still be there. So we're still going to have our dictionary here from here. And it's going to all be encompassed in a single kind of command or a series of switches inside of a single command. And hopefully that gets us back something. And it seems like I know what I'm talking about, but I don't, because that took a lot of research as well. And to be honest, when I was in here, for some reason I thought it would be a good idea to keep on doing backslashes like this or like this, and hoping that some of that would actually give me something, but it didn't, by like doing the ls of this and then trying this. And that was basically me reading through here, hoping that some backslashes or ticks or something that would assist, but that's obviously not the case. Not sure where I got that idea. Anywho, if you think about this thing that I mentioned, so if we actually put an A and we do the web pass? Let's try that. I think it was Natas web pass or something like that. We're gonna have to just go to my answer really quick. All right, so I cheated slightly to grab my answer to remember what it was. So here you can see that it's basically, it could be anything. So we'll start with A to start out. So A is the letter we're looking for. So we're searching for A, and we're going to search for A inside of this location. So we're going to go to ETC, we're going to go to Natas Web Pass, and we're going to go to Natas 11. And then that's going to be the first search, and then it's going to first search for C inside of the dictionary.txt as well. So if I do enter here, you're going to see that it provides back the answer, but I didn't want the answer immediately. Damn it, it's not what I wanted. So let's do A. So when I do A and not C, so if I did A first, I did A, the string, and then see what would happen. And then when I did that, nothing came back. So I kind of like scrolled through here. I looked through this different text to see if there was anything of interest, but it looked like it was just collecting A. So it was looking inside of the dictionary and it was pulling out the A. So we have our key and then our value is what we're getting back. So I said, okay, well, that obviously doesn't have a key and that's not good for me. So I kind of got concerned thinking that I was going in the wrong direction. So then after I did A, then I tried B, and then typed in B, and then B just gave me a bunch of back stuff, and just a B is included in the text. So then I just started trying a bunch of the letters. So I got to C finally, and I did C, and then that came back. And the reason that C came back is if you actually look inside of this, you can see that what it's pulling back is the location that we called. So this is our location. And then this is the key. This is our secret that we need to use to actually put in to get the answer. And what we looked for was C. So if you look specifically inside of this text, it actually has a C listed right there. And remember that the grep is a grep with a -i, right? And this is basically stating that it's case insensitive, so the casing doesn't matter. So you can see that this capital C still was found when we had a lowercase c. So once doing this, we've gotten our key back. We're successful. We can pop that in, and we go to the TOS 11. So internet, I hope that was fun and interesting and entertaining and amazing, and you're super impressed by how ninja I am. Or not, because I'm not at all. The important thing is that we're learning together, and I'm basically Googling my way through every single one of these challenges because a lot of this stuff is new to me. And hopefully in 6 to 12 months, it'll not be, but I'm sure there'll be many new things to me in those times as well. So I hope you enjoyed this, and I will see you next time when we do probably one challenge for one video because this took too long.